Hello guys, let's try this question. In the diagram below, A, B, C and D are points on a circle having center O. PBT is a tangent at center to the center at point B. Reflex B angle OC is equal to angle O1 and is equal to 310 degrees as shown in the diagram below. Calculate giving reasons the size of angle D1. So, looking at the diagram, angle D1 is at the circumference of the circle. Now, let's check the chord BC. The chord BC is subtending angle O2, also subtending angle D1. So, first, let's check angle O2. Angle O2 is at the center of the circle, while the whole part is equal to 310. But the whole circle, the complete circle, is what? Is 360 degrees. That is a revolution. So, now we're going to say, first, we're going to say angle O2 is equal to 360 degrees minus 310 degrees. The reason is a revolution. It's a revolution. So, now we're going to subtract the 310 into 360 degrees. So, 360 minus 310 is equal to 50 degrees. So, it means angle O2 is equal to 50 degrees. So, go back to the diagram now. BC is subtending angle O2, also subtending angle D1. It means the angle at center is equal to the angle at circumference. It means angle O2 is 2 times angle D1. So, we are going to say now, angle O2 is equal to 2 times angle D1. The reason being is the angle at center is equal to the angle at circumference. So, we just say is the angle at center. So now, what is O2? O2 is equal to 50 degrees and is equal to 2d1. Now we divide by 2, d1 is equal to 25 degrees. So it means that the size of d1 is equal to 25. Now we go back to the diagram. Now calculate giving reason the size of B3. So now let's check B3. B3 is the angle between the tangent and the chord. So the tangent, the angle between the tangent and the chord is equal to the interior alternate angle inside the triangle. So let's check triangle BCD. Triangle BCD, there is D1 there, is the angle at the interior alternate. So that means D1 is equal to angle B3. So we're going to say angle B3 is equal to angle D1. The reason is the tan chord theorem, or just say is the tan chord, because this angle is subtended by or is the angle between the tangent and the chord. So it's equal to that one inside the triangle at the alternate angle. So now what is D1? We know that D1 is equal to 25. So it means therefore angle B3 is equal to 25 degrees. Straightforward. Now let's check. There is a question now. They are saying calculate B1. Where is B1? Here is our B1 here. They are saying calculate B1 if it is given that angle A is 60 degrees. So now let's check. Angle this is a cyclic quad. Remember, we have four 4 corners at the circumference of the circle. So this is a cyclic quad. It means what? It means that angle A plus angle C, the whole C, is equal to what? 180 degrees. So we're going to say, okay, this is 8.1, this is 8.2. So 8.3, we are going to say angle A plus, let's call this B angle CD is equal to 180 degrees. The reason is opposite angles of a cyclic quad. Opposite angles of a cyclic quad. Remember, opposite angles of a cyclic quad are supplementary. So supplementary means they add up to 180 degrees. So what is angle A? Angle A is given as 60 from the question, plus B angle CD is equal to 180 degrees. It means what? It means that B angle CD is equal to 180 degrees minus 60 degrees, which is what? Which is 120 degrees. So we'll go back to the diagram now. It means what? It means that this whole angle is equal to 120 degrees, while this one is just 60 degrees. So now remember, we're looking for B1. What is this? This is 25. Remember, we got D1 is 25. So this is 25. Now let's check this triangle B angle, triangle BCD. We have this angle, we have this angle. Now what is that angle? B2. So we're going to say angle B2 plus the whole C, which is angle B angle CD plus angle D1 is equal to 180 degrees. The reason is the sum angles of a triangle. So B2, we don't have B2, we're just looking for B2 plus, what is this? This one is 120. We're going to say it's 120 plus B1 is 25, so equal to 180 degrees. So B2 plus 120 plus 125, simply 145, is equal to 180 degrees. So we take this to the other side. Now we're going to say angle B2 is equal to 180 degrees minus 145 degrees. This is going to give us 35 degrees. It means that angle B2 is equal to 35 degrees. So let's check. Now let's check the diagram. We are looking for B1, but let's check this. We have a radius here, OC and OB. OC and OB are radius. It's radius 1, radius 2. So this OC is equal to OB. That means they form an isosceles triangle. It means that this is an isosceles triangle. C1 is equal to A angle BC. I mean O angle BC. C1 is equal to O angle BC is equal to this whole angle here. So let's say you are going to calculate that angle now. We're going to say in triangle OBC, angle O2, which is this one, plus O angle BC, which is this one, plus angle C1. is equal to 180 degrees. C1, which is this one. So the reason the sum or sum angles of a triangle, that's the reason. So what is O2? O2 is 50. We know that we found O2 as a 50. Now what is O angle BC? That is what we are looking for. So it's just O angle BC and then plus angle C1 is equal to 180 degrees. So, but we said, or we know that this angle is equal to this angle. So let's just say we call all these angles as C1. So 50 plus, we call them 2C1 because C1 is equal to this. We can call them C1. So just 2C1 is equal to 180 degrees. So take this to the other side. We're going to have 2C1 is equal to 130 degrees. 130 minus 50, 180 minus 50 is equal to 130 degrees. So we divide by 2. Angle C1 is equal to 65 degrees. 65, 180 divided by 2, just 65. So it means that this angle here is equal to 65 degrees. But what is B2? B2 is equal to 35, but the whole B1 and B2 is equal to 65. It means what? It means that, let me say, therefore B1 plus B2 is equal to 65 degrees. Remember, C1 is equal to the whole B. The whole B is B1 and B2. So B1 and B2 is equal to 65 degrees. Now, we are looking for B1. What is B2? We found B2 as 35 degrees. So we're going to say this is 35 is equal to 65 degrees. So take 35 to the other side. B1 is equal to 65 minus 35. B1 is equal to 30 degrees. So this is the size of B1.